Hey everybody, here is the homework number 14 notes part 2 video on the difference quotient. So really the idea of the difference quotient is you're finding the slope of a line between 2 points on a graph. So here's what we got. Given two arbitrary points on a graph, we usually call them x comma f of x and x plus h comma f of x plus h. We would like to find the slope between those 2 points. So here's an example function, f of x equal to x squared. And I've got these 2 points. I've got x comma f of x right here, which would actually be x comma x squared. And I've got x plus h comma f of x plus h would be x plus h comma x plus h squared. To find the slope between those 2 points, I would use the slope equation, meaning it's the difference in the y's divided by the difference in the x's. So slope can be found by doing y2 minus y1 over x2 minus x1, which is going to be, in this case, f of x plus h minus f of x all over x plus h minus x. That's always going to simplify to f of x plus h minus f of x divided by x plus h minus x is just h. And that is the difference quotient. So whenever someone says find the difference quotient of a function, the idea is to always find f of x plus h minus f of x divided by h, and then to simplify as much as possible. For the example we just looked at, f of x equal to x squared, we can calculate and simplify the difference quotient by doing the following. So f of x plus h minus f of x all over h, well, our function was x squared, which means f of some stuff, in this case x plus h, is going to be that stuff squared. So we're going to get f of x plus h is x plus h squared minus f of x, which is x squared, all over h. And now our job is to simplify this as much as possible. Specifically, what our job is to cancel the h in the denominator. So let's see what happens. If we multiply out x plus h squared, we get x squared plus 2xh plus h squared minus x squared all over h. X squared minus x squared is 0, so those go away. And we're left with 2xh plus h squared all over h. We can factor out an h from the top and get h times 2x plus h divided by h. H divided by h is 1, so we're left with 2x plus h. That is our final simplified answer. I'll point out that some people prefer, instead of factoring out an h from the top, at this stage they would have just divided each thing by h. So 2xh divided by h plus h squared divided by h, which would equal 2x plus h squared divided by h is h to the first. Either way you do it, you're still going to get 2x plus h. The h is important here. So you might be thinking somewhere in the back of your head, if you had calculus before, oh, don't we let h become 0? That's later on. For now, h is just h. It's sticking around. It doesn't go away. Except for there is one example we're going to see where it does go away, but that's not because of taking a limit or anything. That's just because of the nature of that example. To go a little bit deeper into this, I'll point out that if we had x equal to 3 and h equal to 1, so looking back over here, for example, actually, like if this was the point 3 comma 9, and if this distance was 1 and this was the point 4 comma 16, this would give us the actual slope. The slope between those 2 points is 16 minus 9 over 4 minus 3, which is 7 over 1. But if we have to use the formula, right, x equals 3 and h equals 1, then the slope between the points x comma f of x, which would be 3 comma 9, and x plus h comma f of x plus h would be 3 plus 1, which is 4 comma 4 squared, which is 416. Well, we're going to get exactly what we got there, 2x plus h, and if we plug in 3 for x and 1 for h, we get exactly 2 times 3 plus 1, which is 7. We could also have gotten that slope by just plugging in these 2 points to our slope equation and getting 16 minus 9 over 4 minus 3, which is exactly 7 over 1, which is 7. Or we could have picked any other points. The point here is that this formula actually gives you the slope for any value of x and any value of h. on the graph, or I should say, for any point x and x plus h on the graph. You don't really do this, but I just kind of want to make it a little bit more sense, right? This is the slope of any line like this. I could have picked my points to be here and here and found the slope between them, or whatever. Okay, a couple more examples. Really, this is the whole idea, is you're taking this expression, plugging in your function, and then simplifying it as much as possible, specifically until you've canceled this h in the denominator. That h always has to go. Okay, so let's look at this next example. Find and simplify the difference quotient for g of x equal to negative 5x plus 6. And I want to point out something here. Since g of x equal to negative 5x plus 6 is a straight line, and it's got like, looks like this, kind of. No matter what 2 points you pick on it, the slope between those 2 points will be the slope of your straight line. So since this is a straight line with a slope of m equal to negative 5, we expect that the difference quotient, g of x plus h minus g of x divided by h, will also equal negative 5. That's something that's only true for straight lines. For other functions, the slope between 2 points depends on what 2 points you pick. For a straight line, any two points you pick, the slope between them will be the slope of that line. Let's do it anyway. So g of x plus h, you're going to replace x with x plus h. So it's going to be negative 5 times x plus h plus 6 minus g of x, which is just negative 5x plus 6, all divided by h. I want to point out, the reason I wrote the brackets here is to make sure that I distribute the minus sign here. There's my g of x plus h minus my g of x, all over h. We're going to simplify a bit. Let's distribute the negative 5 and get negative 5x minus 5h plus 6. Let's distribute the minus sign here and get minus and minus is plus 5x minus 6 is minus 6 all over h. And what should happen here before we cancel out the h is all the things that don't have an h in the numerator should cancel out. Negative 5x plus 5x is 0. 6 minus 6 is 0. That's why it was really important that we distributed this minus sign, otherwise the 6's wouldn't be canceled. And then that's going to equal negative 5h divided by h, but h divided by h is 1, so we just get negative 5, as expected. So for straight lines, the difference quotient should always end up equaling the slope of that line. You still need to show the work, though. Let's do one, maybe we'll do 2 more, but let's do this one first. So let's find and simplify f of x plus h minus f of x over h, the difference quotient, for this function here. And before I actually write this out, I'm actually going to write out what f of x plus h is. So f of x plus h is 2 times, instead of x cubed, it's x plus h cubed, minus 6 times, instead of x, it's x plus h. Let's multiply this out. And there's a trick for multiplying out x plus h cubed. I don't remember if I talked about it in class or not, where we use this thing called Pascal's triangle. These are the coefficients for x plus h cubed. So that's going to end up equaling 2 times 1x cubed plus 3x squared h plus 3xh squared plus h cubed minus 6x minus 6h. And if I distribute this a little bit more, I'm going to get 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed minus 6x minus 6h. I said h, but I wrote x before. Sorry about that. Okay, now let's write it all out. So then f of x plus h minus f of x all divided by h is going to be, well, again, f of x plus h is all of this. I'm not going to write it again starting from here. I'm just going to write it all out. It's going to be 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed minus 6x minus 6h minus my f of x, which is just 2x cubed minus 6x all over h. I'm expecting this term and this term to cancel out because those are the ones that don't have h's. Let's take a look here. If I distribute the minus sign, I've got still 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed minus 6x minus 6h minus 2x cubed plus 6x all divided by h. The 2x cubed and the negative 2x cubed out to 0. The negative 6x and the positive 6x add up to 0. So I'm left with 6x squared h plus 6xh squared plus 2h cubed minus 6h, all divided by h. Factor out an h from the top. 6x squared plus 6xh to the first plus 2h squared minus 6 all over h, and h divided by h is 1. So we're left with 6x squared plus 6xh plus 2h squared minus 6 is our final answer. And that's really all there is to the difference quotient. You plug in x plus h to your function, and then your function of x plus h minus your function of x. You expand it out as much as possible. You then simplify it by canceling in terms of cancel. And again, what should happen here is everything in the numerator that does not have an h, so the 2x cubed here doesn't have an h, and the 6x doesn't have an h, those should cancel out. Everything else has an h in it, so we're good to go. Then we can factor out an h from everything else that's left in top, and then that h you factored out divided by the h in the denominator is just 1, and then you're left with just whatever was in that parentheses there. That's the usual process. All right, that is all I have got.